In the previous video, we have seen the impulse commutated chopper in detail. This is the circuit of impulse commutated chopper with 2 thyristors and 1 diode. The chopper operation consisting of 5 modes of operation. In that, the undercharging of the capacitor mode is mode 4 can be eliminated simply by replacing the diode D1 with a thyristor T3. Now this became the impulse commutated 3 thyristor chopper. It's having 4 modes of operation. That first one is resonant reverse current mode. Second mode is commutation mode. Third one, overcharging mode. And fourth one, the freewheeling mode. Here the fourth one is undercharging mode in case of impulse commutated chopper with 2 thyristors and 1 diode. That is eliminated. The mode 1 is resonant reserve current having the equivalent circuit LS through thyristor T1. The supply goes to the load back to Vs. Ia equals to Is itself. During this operation, we have come across the resonant current, that is IR, equals to Vc square root of C by Lm sine omega m of t, where omega m equals to 1 by square root of Lmc. The peak value is IRP equals to Vc square root of C by Lm. And the voltage of the capacitor Vc of t is equals to Vc cos omega m of t. These are all as same as in the impulse commutated chopper with 2 thyristors and 1 diode. After the time t equals to tr, that equals to pi square root of Lm of c, by firing the thyristor T3, the voltage Vc, which is plus and minus before, is going to be reversed minus Vc at this time due to the resonant reverse circuit consisting of T1, T3, Lm, C. And remember, T1 and T3 should be fired at a time. Now, the capacitor is ready for commutation. This is regarding mode 1. Now, mode 2. Mode 2 begins when commutation thyristor T2 is fired and the capacitor C discharges and recharges through the load at a rate determined by the load current. As the T2 is fired, T1 is going to turn off. Now this Vc is negative. In this we come across the circuitry turn off time T off equals to Vc C by Im, and the recharging time Td equals to Vs C by Im. Then the commutation time T C equals to T off plus Td. And the second mode is going to end at T equals to Tc. Capacitor C recharges minus Vc2 Vs, and the freewheeling diode Dm is going to start at the end. If you observe these equations, the Tc commutation time is going to depend upon circuit turn off time and recharging time Td, and both the times is going to depend upon the load current Im. So in a good chopper, the commutation time Tc should be independent of the load current. Tc could be made less dependent on the load current Im by adding an anti-parallel diode across the main thyristor as shown here. Due to this addition, commutation time is going to be less dependent on the load current Im. Now, mode 3. The mode 3 begins when the capacitor is recharged to the supply voltage Vs and the freewheeling diode Dm starts conducting. So, the equivalent circuit will be. During this mode, the capacitor overcharges due to the energy stored in the source inductor Ls, and the load current decays through the freewheeling diode Dm. This mode ends when the overcharging current reduces to 0. The current is given in this mode Is of t is equals to Im cos omega s of t, where omega s equals to 1 by square root of Ls of c. Now the instantaneous voltage V c at t is equals to Vs plus Im square root of Ls by c sine omega st. As the overcharging current becomes 0 and the capacitor is reached to Vx, which equals to Vs plus delta V. That delta V is the over voltage is given by Im square root of Ls by c. Mode 4. Mode 4 begins when the thyristor T2 stops conducting, the freewheeling diode Dm continues to conduct and the load current continues to decay. The equivalent circuit is load connected to a freewheeling diode Dm. Mode 4 is going to end at the next cycle when the thyristor T1 is turned on again. This is how the impulse commutated 3 thyristor chopper works, and the equations for classical chopper, that is impulse commutated chopper having 2 thyristors 1 diode, are valid for this chopper also, except for mode 4, since the mode 4 is not present in this. The charge reversal of the capacitor is done independently of the main thyristor T1 by firing thyristor T3 in mode 1. To do that, we have a simplification that T3 and Lm is across the capacitor C as shown in this figure. This is modified version of the impulse commutated 3 thyristor chopper, and the minimum on time of the chopper is not limited. However, the commutation time is dependent on the load current. In mode 2 we have seen that, and the higher frequency operation is limited. For the main circuit of the impulse commutated chopper, we have made 3 modifications. That first modification is replacing the D1 with the thyristor T3. Induct charging of the capacitor can be eliminated. And the second modification, introducing a diode across the thyristor T1 to reduce the effect of the load current in the commutation time. Third modification is making this Lm and T3 across the capacitor C. Resonant reversal is independent of the main thyristor. Finally, we got this modified impulse commutated 3 thyristor chopper, ICTTC. The waveform is as same as the impulse commutated chopper. So refer the topic of the impulse commutated chopper. The link is given in the description. If you feel this video is useful for you, please like, share, subscribe and comment.